welcome to lecture number 72. We are studying circuit analysis, and in last lecture we started studying transient analysis, and we studied the expressions for current and voltages in a capacitor. The current through a capacitor I sub c of t is the capacitance times the rate of change of the voltage across it, whereas the voltage across capacitor is written in terms of inverse of C, 1 over C, the integral computed over the current for time minus infinity to t. In this lecture, we'll study similar expressions for inductor. We know that for an inductor, the voltage drop across an inductor is equal to the rate of change of flux, and we know that magnetic flux can be written as L times I. So the voltage drop across inductor can be written as L times the rate of change of current. This expression is opposite to the expression we wrote for capacitor. For capacitor, the expression was this: I sub C of t is C times the time derivative of voltage. Here the voltage is equal to L times time derivative of current. So these are opposite to each other. I is computed as it is directly proportional to the derivative of the time derivative of voltage. Here V is the voltage is directly proportional to time derivative of current. Similarly, solving this equation further gives us that I in inductor is 1 over L times the time derivative of voltage. And we studied in last lecture that this quantity, the quantity that involves an integral, cannot change all of a sudden. We studied in last lecture that in case of capacitor, the quantity Vc of t that is computed as an integral of time cannot change all of a sudden. It cannot change suddenly. And we studied that voltage across capacitor cannot change suddenly, whereas current can. In this case, the expression or the statement is reverse. Here, current cannot change all of a sudden. In inductor, current cannot change all of a sudden, suddenly. So, and in last lecture, we also introduced the concept of t is equal to 0 minus and 0 plus. T is equal to 0 minus means that if we have this switch circuit, the circuit having a switch, and it is open initially, and at time t is equal to 0, it is closed. T is equal to 0 minus is the time just before closing the switch, and 0 plus is the time just after we have closed the switch. So in this case, I of 0 minus would be 0. And there is no current. Since there is no current in the circuit, there will be no voltage drop across resistor or inductor. But once we have closed the switch, since current through inductor cannot change all of a sudden, it becomes open circuited. In last lecture, we studied that when we close the switch, the voltage drop across capacitor, there was a capacitor here instead of inductor. In last lecture, there was a capacitor here, and the voltage drop across capacitor couldn't change all of a sudden. Therefore, it was replaced with a short circuit. Here, it is replaced with an open circuit because the current cannot change suddenly through an inductor. So I would be 0 because there is an open circuit here. V across resistor is 0, and V across inductor would be the same as the applied voltage because it is open circuited across inductor. So the conclusion of this and the last lecture is very simple. The current and voltage, these are the two quantities. Current through inductor cannot change suddenly. Since current through inductor cannot change suddenly, so for very sudden changes of the applied voltage, it will be replaced with an open circuit at time 0 plus. And voltage cannot change suddenly across capacitor. Therefore, for sudden variations in voltages, it will be replaced with a short circuit. We will continue studying more about transient behavior of RC and RL based circuits in our upcoming lectures. Thank you.